Okay, so we are gonna finish up limits today, give the rest of the time to work, and then, this is being recorded for those who aren't here. Yesterday's, or whatever day it was also recorded. So if you need to go back and look at intro to limits, and then solving limits algebraically, the last two things, for this week, for this year, actually. And then Tuesday is going to be an odd day. No, Tuesday's an even day. So then we'll see you here on Tuesday and Thursday.
Monday's the odd day?
Monday's an,
Well,
no,
regular?
Monday's not all day.
So we don't have
No.
it all day next week?
What's Friday?
Half day?
Friday's a half day.
No, what's Fridays? Tomorrow is an even day, right?
Oh, yeah.
So Monday's even, so it goes even, odd, and then half day, field day, whatever. So we're not, there's no classes we take
We
on
go to our
Friday.
advisory on Friday next week?
Yeah, you go to Friday in the morning, advisory in the morning, and then you go to whatever field day they're doing. I haven't seen a schedule, so. Which means, we take this today, last particular topic, last, bit of notes, and then you have a quiz next week. Okay, final quiz. And then, of course, everything should be done, and grades should be final in here Thursday, I'm hoping. So, we'll see. These people won't be taking their quiz until Thursday, cause they're not getting back from DC in time, so. But the rest of us should be taking it on Tuesday. Any questions with the last couple days? It's only 4 of you.
No.
Alright, so on Tuesday, we looked at introduction to limits, we looked at limits on a graph, we looked at, what exactly is a limit?
Like when two are approaching a number. I don't know if I have like an exact.
Do you have the right words?
Study of, no, it's calculus.
Wasn't it just like the closest to being like the number that it can't be?
Okay, or not undefined, or what number is it approaching? You said the word approaching, that's really what we're looking for. It's as you're moving along a function, as we have whatever the function may be, something in here like this, okay? And then we pick out a value of x that will give you a value, let's say x equals, I don't know, maybe 4, is what value is the function approaching, what y value is that function approaching as I get closer and closer to 4. Whether or not it exists there or not, whether or not it's defined there, doesn't matter. In fact, I don't even care what the value is actually at that point. I don't even care what happens. I'm just worried about what's happening as I get closer to it, as I approach that value. Okay? So we looked at those with graphs, we looked at those with looks at right hand, looking from the left hand, looking from the right hand. So today we're actually going to solve or prove, if you will. I hate to use that term loosely. We're going to prove some limits. We're going to prove it algebraically. I'm going to give you maybe 2 or 3 tricks to use to solve limits. So the first one, remember, is always direct substitution. I had a student come in here earlier today. They had the limit as x approaches 2 of 1 minus x squared. Okay? That was the problem. It's in the homework. Okay? Here's a homework problem. The limit as x approaches 2 of 1 minus x squared. What's always the first step?
Substitute.
Say it again.
Substitute.
Directly just plug it in. 1 minus 2 squared equals 1 minus 4 equals negative 3. I got a number, right? I got an actual value. That's my answer. This equals negative 3. Don't make that any more difficult than what it is. You just simply substitute it in and solve. The problem comes in when I get something like 0 divided by 0. Okay, so maybe I have something like, let's see, we did one the other day, right? We did one, the limit as x approaches 2 of x squared minus 4 over x minus 2. Okay. So I directly substitute. First thing, just substitute it. What is 2 squared? And 4 minus 4 is 0. And 2 minus 2 is 0. So I have this form 0 over 0. And what name did we give that? It wasn't undefined.
Indeterminate.
Indeterminate. Okay, this is what we call indeterminate. Unable unable to be determined. We have to do something to that. So this is what I'm looking for. If I end up with 0 over 0, what is 0 over 4? Is 0. It's perfectly fine. What about 3 divided by 0? No, it's not 0.
It's 3.
It's not 3. Can you divide by 0?
No.
No, so that's considered to be
Undefined.
undefined. That's undefined. It's not indeterminate. So this is 0, this is undefined. Those are your answers. Okay, you're done. You're finished. If you get a value like -3, answer's -3. It's when we get 0 over 0, that's going to be my, okay, I got to do something else too. Okay? I got to do something else to prove what the limit is. Okay? So the first one is, we're going to go through this list. Number 1 is direct substitution, if you haven't written that down yet. Number 1, direct substitution. If you get an answer, you're done. If it's 0 or 0, then there's a couple of things we can do. The first one I'm going to show you is factoring. Sometimes it's called canceling. Okay, canceling or factoring, whichever term you prefer. Okay, so let's give you an example. In fact, we'll go back and do the one we did yesterday. Number 2, factoring. Sometimes called canceling. Nothing new, we've done this 1,000 times before. Let's do the one we did yesterday. The limit as x approaches 2, and I'm saying this over and over, hopefully you're catching how what it means, how it's worded, of x squared minus 4 over x minus 2, or you could put that all in parentheses. X squared minus 4 over x minus 2. Now yesterday we did this, or on Tuesday we did this, and we figured out what's the answer. Yeah, quickly. What do we figure out the answer is? Look back in your notes. Remember we did the little table?
I brought the wrong.
Well, then it's only you. What do we get the answer on Tuesday for? We did the little table, calculated the numbers as we get closer and closer to 2. What do we say?
2 over 4.
Then just the 4. Because the top number is the x. I'm getting closer to 2. So we determined the answer was 4. Okay. Well, here's how we're going to do this to prove it, if you will, algebraically. We're going to continue with the limit as x approaches 2. X minus 2, there's nothing I can change on the bottom. But what can I do to the top? How can I factor x squared minus 4? X minus 2 and x plus 2. The difference of 2 squares, right? Okay, so I factored it. What cancels? The x minus 2 cancels. So I end up with the limit as x approaches 2 of x plus 2. Okay, Ms. White, what's the first thing we want to do now? I've already factored it. Now I come back to this one. Then I'm going to substitute. Then you directly substitute. I get 2 plus 2 equals 4. That's not 0 or 0, so I'm done. Okay.
But then if it was 0 to 0, we would
Factor again, see if you can cancel something else. Do another.
we would do
different.
the same number 2 over and over till we got it.
You do something until you get an actual number. Normally, when it comes to polynomials like a rational, one thing, things will cancel, you get your answer. There is a couple probably into this year that you may have to do it 2 or 3 times.
So the 3 and 4 are different ways to do it that you're gonna show
Yes.
us?
2 is, they're tricks.
Okay.
And you're not gonna do them, you're not gonna do step 1, step 2, step 3.
It's either or.
You do direct substitution first, and then you pick from a list. When you come to calculus class next year, there'll be a list of like 7 things to do. Okay, 7 different things. I'm gonna teach you 2. Direct substitution, we're gonna do factor canceling. Then I'm gonna show you conjugates, and we're done. Okay. So the first one is just factor, cancel it, do something. See what? Keep going away. Welcome back. Okay. Okay, Okay, so let's do another example like this. So if you want another example, the limit as x approaches 3, we'll do a basic little rational function, x squared minus x minus 6 over x minus 3. Okay, so what's the first thing I'm going to do? I didn't hear you. Substitute. So I'm going to go 3 squared is 9 minus 3 minus 6 over 3 minus 3. Say it again.
If we know 0 is going to be in the bottom, can we just
I can't hear you. Speak up a little bit.
if we know that 3 minus 3 is 0, can we just stop there? Like after the
No, because what the top number would be like 12. Well, that's like 12 over 0. Then it's undefined. Okay, so you have to do top and bottom. So 9 minus 3 is 6, 6 minus 6 equals, it has to be 0 over 0, you have to confirm that. Because once again, if you get 3 over 0, now your answer is undefined.
and 9, 0.
Okay, so if it's not 0, 0, you got a different answer.
So, Phillips,
Yep.
so we're looking for it to be 0 over 0?
Yes, when you have 0 over 0, that means it's indeterminate. You have to now factor, cancel, some sort of trick. Okay, so I got 0, 0. So let's go back and let's factor it. The limit as x approaches 3, what is x squared minus x minus 6 cancel to, or factor to?
Plus 6, wait, x and then minus x plus 6 and x minus 6?
Okay, now,
I mean,
this is a textbook problem, right?
yeah.
We're teaching you how to do it. X minus 3 is going to be on the top. One of the factors is going to be x minus
So
3.
then x plus 3.
What's the other one?
X plus 3
No. X plus 2.
is-
Because
it's
negative 3
squared.
times 2 is negative 6. Negative 3 plus 2 gives me negative 1. Okay? So this is a textbook problem, meaning it's not like a real life problem right now. So whatever's on bottom is probably going to be on top. Okay? Because this way it's going to do what?
Cancel.
This way it's going to cancel. So you're going to be left with the limit as x approaches 3 of x plus 2. So then what's your answer?
6.
Did you just say 6?
It's 5.
5.
Oh,
3 plus 2.
3 plus 2, yeah.
3 plus 2.
Oh, yeah, the second one is.
Just plug it in. So the first one, factoring and canceling, just factor it, see what cancels, directly substitute again, and you're done. Make sense?
Yeah.
Try one on your own. You try. Start off with the limit as x approaches 1. So because it's a textbook problem, what's going to be the denominator?
3,
No.
1.
As x approaches 1, so the denominator is going to be
Negative 1.
x minus 1. The top is going to be x squared plus 2x minus 3. Now remember, don't forget to plug in first. Make sure you get 0, 0. Okay, first thing we should have plugged it in, you got 0, 0, correct? Alright. What is the top factor to?
X plus 3 times X minus 1.
X plus what?
3.
3 times x minus 1. 3 times negative 1 is negative 3. 3 minus 1 is 2 over x minus 1. So we're left with the limit as x approaches 1 of x plus 3. So what's my answer?
4.
1 plus 3.
4.
You need to bring your glasses to school.
I'm sorry.
I'm sorry.
Yeah.
I'm really sorry. I'm really stopping to have
Okay, I'm sorry.
sympathy for you. So yeah, you just plug it in. 1 plus 3 is 4.
I was thinking.
Please don't make this harder than what it is. It's just direct substitution. Because this next one will be on the quiz, and it's a little more tricky. Okay, you got this one?
Yeah.
Directly substitute, factor if you can. Sometimes you can't factor.
Like if we use like we factor, will they always cancel out and then you could get a like addition problem? Will it always be like that?
Will you always, like, as far as on homework and the quiz, or will always as in real life math?
As in the homework and
Yes. As in while we're learning it, they'll always cancel. As in you come across a real life situation, maybe not. And which is why we have 7 different tools we'll use to figure it out. Alright. So, number 3. Number 3 is we're going to rationalize or sometimes we refer to it as using the conjugate. Now, probably need to review what exactly is the conjugate. I've taught it to you before in Algebra 2 and in PreCalc. Let's see if we remember what it is. So, a little scratch paper here. Let's come up with x squared minus 9. What's x squared minus 9 factor?
So it's going
X times X.
X plus 3 and x minus 3. Because you can multiply it out. X times x is x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. 3 times negative 3 is negative 9. And what always happens to them two middle terms? They cancel each other out. Those are conjugates. Okay? Those are conjugates. Exactly the same numbers. The only difference is one's plus, one's minus. Okay? So if I give you, let's say I give you 2x minus 3, what is its conjugate? I give you 2x minus 3. What is its conjugate?
Negative 2x.
No.
2x plus 3?
2x plus 3. Don't make it more difficult than what it is. 2x plus 3. That's the conjugate. Okay? If I give you, let's say, x plus y, what is its conjugate? X minus 1. Okay? You get it?
Yeah.
How about this one? This is going to be a little tricky. Are you ready?
Yeah.
What if I give you the square root of x plus 1 minus 3? What is its conjugate?
Square root of
The square root
x plus 1
of x
plus
plus 1 plus 3. The only thing that changed is the sign in between. Okay, does that make sense?
X plus 1 will stay x plus 1, right?
The only thing that changes is the sign in between the two terms. You don't change the first term, you don't change the second term, you just change one's plus, one's minus. Okay? Here we go. Example. The limit as x approaches 0 of the square root of 4 minus x. Is that what I wanted? No, square root of 4 plus x minus 2 over x. Okay, so what's the very first thing we're going to do?
Substitute.
Okay, substitute. So get it written down, and then we'll substitute it in. So we're going to plug in 0 every time we see x, right? All right, so the square root of, what is 4 plus 0?
4.
Outstanding. Minus 2 over, in place of x, I'm going to put 0. Now, it's not necessarily indeterminate, because once again, if I get 5 over 0, it's undefined. What is the square root of 4? 2. 2 minus 2 over 0 does give me 0 over 0. So now it's indeterminate. Okay? All right, so out of the way. So let's take this and let's multiply, because you can't factor. I mean, there's nothing to factor on the bottom. You really can't factor the top. Okay? So that's sort of the key. You look at the top and you're like, there's no way I can, that's not a rational expression. There's not a polynomial on top. So I'm going to have to do something different. So let's go ahead and multiply by, let's use a different color. See if it'll change. There we go. So let's multiply, and let's take, seriously, yellow, stay there. And let's multiply by, let's take the conjugate of the top.
4 plus x plus 2.
Square root
Oh, yes.
4 plus x, change the subtraction to plus 2. Okay, see how I got the conjugate? Just change the sign. Now if I multiply that on top, what do I have to do to the bottom?
The same.
Exactly the same thing.
So
Square root 4 plus x plus 2. Okay, so the limit. As x approaches 0, the bottom, I'm just going to multiply those together. So I just have x times the square root of 4 plus x plus 2. That's not going to change. Now, when I multiply the 2, what is the square root of 4 plus x times the square root of 4 plus x?
Square root of 8 plus x squared.
Okay, so, scratch paper. What if I take the square root of 2 times the square root of 2? What does that equal? I'm sorry?
Square root of 4.
What's the square root of 4?
2.
Just 2.
Yeah.
If I take the square root of 10 times the square root of 10, what's that going to be equal to? 10.
10.
If I take the square root of x times the square root of x, what's that going to be equal to?
X.
X. If I take the square root of x plus 1 times the square root of x plus 1, what's that going to be equal to? X plus 1. So if I take the square root of 4 plus x times the square root of 4 plus x, what do I have left? 4 plus x.
Oh my God.
Now, because we know what conjugates do, I know that when I take the square root of 4 plus x times positive 2 and the square root of 4 plus x times negative 2, what's going to happen?
We cancel.
2 middle terms will always cancel. So I don't have to worry about doing the middle 2. So then what is the square root of 2, or I'm sorry, negative 2 times a positive 2?
Negative 4.
Negative. Now, I have the limit as x approaches 0. On the bottom I have x times the square root of 4 plus x plus 2. What do I have on top?
4 plus 0 minus 4 is just 0.
I'm sorry?
4 plus 0 minus 4.
It's
It's negative 4. No, yeah, 0.
4 plus 0 minus
We're not substituting it yet. I haven't said substitute in x.
4 plus x minus
What is 4 plus x minus 4?
8.
Is it just x?
0. 0 plus x.
What'd you say?
X.
Just x, because 4 minus 4 is 0. So I'm left with just x. Not sure why you're laughing.
Dang.
Then we have the limit as x approaches 0. I have an x on top and an x on bottom. You see an x on top and x on bottom? What happens to those two? They cancel. So I'm left with 1 divided by the square root of 4 plus x plus 2. Now substitute. One over, what is 4 plus 0?
4.
Square root of 4 is,
4.
2.
square root of 4 is 2, right? And 2 plus 2 is?
4. That's why I said 4. I know you're just asking 4.
Gotcha.
Right.
So your answer is 1/4. So by multiplying by the conjugate, what I've allowed myself to do is actually get the actual number. Have I changed the value of this? No, because I just multiplied by 1. The same number divided by itself is just 1. I just changed the way it looked, allows me to actually solve the limit, and I go with 1.
Do you have to wait till the end to
I can't hear what you're saying.
Do you have to wait till the end to substitute?
Yes. You have to wait till the end. You have to wait until you can plug it in and not get 0 or 0. Because if I plug 0 in here, you would have ended up with 0 over 0. Because top is 0. What's 0 times anything? 0. I would have ended up with 0, 0. I've got to wait until I cancel something or change it in some way
To give that value.
in order to get something other than 0 over 0. Let's try another one using conjugates. Last one, example. You're leaving kind of early, aren't you?
I read the bus.
The limit as x approaches 0, square root of 9 plus x minus 3 over x. Same exact type of problem. Hey, good morning. Who's telling you we're not doing it?
They forced me, like they said, go to the library. I was like, okay.
Awesome. So your name can come off my list. You're not even on my list.
I had 2.
Oh, it wasn't math?
Mm-mm.
You skipped pre-calculus class.
I didn't skip.
It's not your
They
fault.
forced me to go down
It's
there.
not your fault. I'm just sitting here going, why would they? Well, Danny can check. It's pretty easy, right?
Yeah.
Yeah.
Where did our phones?
Mom's going.
What's the question?
Where's everyone else?
Well, Jalen, Jennifer, and Savannah are on their way to, if they're not there, in Washington, D.C. for rocketry. Elijah, Yana, and Jaya are gone because they're seniors. And Giselle and Evan, is that it? Just the two of them? Are taking some test. And Amaya is earlier today. So. But you're here. All right, so what's the first thing we do? What's the first thing we do? Substitute, so plug in 0. So, did y'all do that?
Yes.
9 plus 0 is 9, minus 3 over 0. We see that we get 3 minus 3 over 0, 0 over 0. On the test, I promise you, I'm going to put one on here that looks like it's going to be 0 or 0, but when you plug it in, it's not. And you get a nice little answer. Because what happens when that occurs? When you plug it in and you don't get 0 or 0, you're done. Okay, if it's a number, it's a number. If it's divided by 0, it's undefined. That's your answer. You're finished.
You promise?
I'm sorry?
You promise you gonna give us
No.
one?
So then, because I cannot factor this one, someone tell me, what am I going to multiply by? What am I going to multiply by? Scholar? What will I multiply by?
3.
No. Have you not been listening this whole time?
Square root of 9 plus x plus 3.
Boom, there you go. The same thing, just change the sign. The square root of 9 plus x plus 3. Divided by, remember it's got to be exactly the same thing. Square root of 9 plus x plus 3.
Wow, why do you put in like a big gap between them?
Between these two?
No, like
You mean plus 3.
Oh.
no, like plus 3 minus. Even like on the other example, is it just like to make sure we know to switch it on the conjugate?
Part of it's that, part of it's I'm writing backwards, part of it too is I want to make sure that's not underneath the radical.
The square root.
Just to make sure we know it's not under the radical. Okay, see if you can follow this one through like the last example to the end. So, this is a classic mistake with limits, okay? What Ms. White did was, I'm not pointing you out, I'm just saying, a lot of kids do this, is they wrote just that. Okay, and you forgot to write the limit. Always put this out front. I know it's kind of redundant, but that helps us remember, oh wait a minute, I'm eventually gonna substitute 0 in for x. Because that's where you are. You're at the place you can put the 0 in for x. Well, always write it so that you know. Okay? So on top we end up with just x, right? And you have the limit as x approaches 0. You have 1 over the square root of 9 plus x plus 3. But remember, the limit tells me I plug 0 in for x. Okay, so plug 0 in for x and tell me what you do. Is what, 12? What's the square root of it? What times 1 equals 9? 3. So you have 1 over 3 plus 3. So you should get 1/6.
Can you do this steps before this?
I'm sorry?
Because I got stuff right before.
You mean to get here?
Yeah.
Okay, so what you do is you take the square root of 9 plus x times the square root of 9 plus x, which is what? 9 plus x.
Okay.
And then what happens to the middle two?
Yeah.
Cancel? What's negative 3 times positive 3?
Negative 3, negative 3, right? Negative 3 times positive 3. Negative 3.
Please tell me you're not saying that 3 times 3 is 3.
Negative 9.
Negative 9.
That's not funny, sorry.
Okay. So then what is 9 minus 9?
Oh, yeah, okay, that's what I messed up.
And the x is canceled.
What I did, I don't know why, I just, like, you know how you said the parentheses? Oh, okay, I thought, I made it seem like the parentheses was over the whole thing, and I just canceled the parentheses. But it's not what it is.
Alright. Alright, so that's pretty much all I got for you. You have a homework assignment on page, wherever. I do have the test in front of me, the quiz, the final quiz. Here's your study guide, you ready? And then I'm gonna turn the camera off and we'll answer any questions you have. Numbers 1 through 4, this is the end of the year quiz, which means it's worth 40 points, which means that notes may be used. Officially, okay? Numbers 1 through 4 are sequences and series. In other words, I may ask you a question like, given, for example, given a sub n equals, I'm sorry, not a sub n. Given a sub 1 equals 12, d equals 2, and n equals 54. What type of sequence is it? I've given you a d, that's your hint. Arithmetic. Okay? Find a sub n, or find the 54th term, because n equals 54. So there you just use your formula. N over 2 times a sub 1 plus a sub 54. Or I'm sorry, that's for a, so I'd use a sub 1 plus n minus 1 times d. Use your formula. Or I might say find s of n, which would be s of 54. So there you would use your formula for this sequence. I'm telling you right now, number 1, find a given term arithmetic, find the sum of an arithmetic. Number 3, find a certain term in a geometric, find the sum of a geometric. One of each term. So you use all four of those formulas once. You good?
Yes, sir.
Number 5 through 6. Our sigma notation. I give you a function, something like I equals 1, 2, 3, 4i squared, solve. I'm not going to give you, I equals 1 to 3,000. One of them is to 3, one of them is to 5. So at most you're going to have 5 terms.
Huh?
7 through 10. Limits. Algebraically. Like we did today. I will tell you, yeah, 2 of them are just like today, 2 of them are you just plug in, they're done. Like for instance, maybe I give you the limit as x approaches 3, maybe something like the square root of x minus 1 over x, something like that. Plug it in, what do you get? Plug
2
in,
over-
what?
2 over 3?
Not quite.
1 over.
You were
1
close.
over 3.
You said 2 over 3?
Yeah.
Very close. You're missing a symbol.
2 over 3, yeah.
The square root
Square
of
root of
2.
2 over 3.
No, we need to go anymore.
Really?
That's it. That's actually number 10. Different numbers, but the same type of problem.
Oh.
Now, would it change? This is for the camera, for those of you paying attention. This is for you watching. It doesn't matter if I put a one-sided limit there and put a plus sign. Does it change anything? No. What if I put a negative here?
It would be 4 over.
What if I put a negative there?
Square root of 4. Or
Nope.
square root of 2.
Doesn't change anything.
Really?
Do exactly the same way. You
Oh.
plug in 3, if you get a number, you're done. Doesn't change anything.
So you're actually getting is 0, 0 on all of them?
2 of them end up 0, 0. I'll be honest with you, one of them is the factoring type, and one of them is the conjugate type. Very simple. Straightforward. Tell you exactly what's on, no surprises. Alright, number 11 through 12. I'm sorry, I lied. 11 through 14 is from a graph. So I'll give you something, one of these piecewise functions, something like something like that, and then say what's the limit to this number, what's the limit to that number. We did that yesterday or Tuesday in class. I'd have to create a better graph to actually do some examples, but we can do that if we need to. But it's also in the homework. And that's the quiz, 1 through 14. You have 2 homework assignments, one from Tuesday, one from today. The quiz, that's it for the year. Get ready for calculus. We'll turn the camera off and then we'll. No reason for people to listen to questions.